In this video, we're going to talk about the difference between prime and composite numbers. Now, let's take any number we can think of. Let's say 10. All right, we have the number 10. Prime and composite numbers come from whether or not 10 has lots of factors or not that many factors. So I'm going to start by making a factor rainbow for 10. Well, let's see. The first arch of my rainbow is going to be 1 times 10. Those two factors can multiply together to have a product of 10. All right. How about 2 times 5? Also a factor pair of 10. 3 times, no wait, 3 doesn't work. 4 times, that doesn't work either. 5 times 2, oh but wait, I already have 5 right here. So I'm not going to repeat that factor pair just backwards because I already have that pair written down. And I don't need to repeat and rewrite them in different orders if I already have those two numbers together. So 10 has two sets of factor pairs. I could make two different area models from those factor pairs. 1 by 10 and 2 by 5. Because it has more than one factor pair or more than one area model, 10 is a composite number. Composite means that a number has more than one factor pair or more than two distinct factors, which in turn means that it can make more than one area model. Let's try another one. 2. What factors make 2? Well, 1 times 2 makes 2. So does 2 times 1, but that's not another distinct factor pair. That's just repeating the same factor pair I have. So I just have this one little arch in my rainbow. The only area model I can make for 2 is 1 by 2. Therefore, if I can only make one area model, or I only have one factor pair, or two distinct factors, 2 is a prime number. Prime has only two factors, 1 and me itself. So a prime number like 2, its factors are 1 and itself 2. That's it. So prime number only has one area model, one factor pair, or two distinct factors. Let's try another one. 120. Well, big number. Probably going to be a big rainbow diagram, so I'm going to give myself some space. 1 and 120 multiplied together make 120. 2 and 60, notice I'm still separating my rainbow diagram with commas, make 120. 3, will 3 work? Well, here's how I check. I'm going to find the digital sum of 120. 1 plus 2 plus 0 equals 3, which is divisible by 3, so 120 has to be divisible by 3. So 3 and, even if I figured out that 3 is a factor, that doesn't necessarily mean I know what it is. But since we're working with multiplying two numbers together for factor pairs, the inverse or opposite of multiplying is division. So I could divide 120 divided by 3 and say, well, 3 goes into 12 4 times with no remainder. Bring down that 0. 3 goes into 0 0 times. 40 must be my other factor pair. And if you didn't believe me, we could go back and double check by multiplying the two of them together, and the product should be 120. Keep it going. 4 times 30 will give me 120. Oh my, I'm already running out of room. 5, 120 has a 0 in the ones place, which means that it must be divisible by 5. Again, you don't have to know off the top of your head what that is. You can do that division out and find your other factor of 120. So let's see, 5 and 24, 6. Let's check it. So to be divisible by 6, 120 has to have a factor of 2 and a factor of 3. Since it has both, I know 6 is also going to be a factor, and oh boy, I already ran out of room, even though I knew it was going to be a big one. All right, 6 is going to go into 120 20 times because 6 times 2 is 12 and we add a 0 to make it 120. 6 and 20. 7, nope, not a factor. 8, well, let's see. I know 4 and 30 were factors, so I'm going to double 4 to make 8 and take half of 30, and that means that 8 and 15 are also going to be factors of mine, and I'll make this a little much nicer in a second. 9, well, 120 is divisible by 3, and 9 is divisible by 3, so let's check. Does that work out? Well, that would also mean that 40 would have to be divisible by 3 for 2 sets of 3 times 3, which it is not, so 9 is not going to be a factor of mine. 10, however, will, because the ones place is a 0, so 12 and 10 would be my last factor pair. If I were to rewrite this out in a much nicer way, we would have 120. All right, here's our final factor rainbow for 120. Whew, it was very large. And looking at that, I'm going to ask you, is this a prime or composite number? Does it have more than one factor pair? Oh yeah, it has 1, 2, 3, 4, 5, 6, 7, 8 different factor pairs, meaning it would have 8 distinct area models, which is way more than the one distinct area model that would make it prime. Anything more than one distinct area model means that it is a composite number, so 120 is composite. The point that I wanted to make here between 120 and 10, 120 has a ton of factor pairs, 10 has 2. Just because 10 has fewer factor pairs or area models than 120 does, doesn't mean that they're called something different. They are both composite numbers because they have more than one factor pair or more than one distinct area model. So it doesn't matter how many more than one they have, if they have more than one area model or if they have more than one distinct factor pair, which makes that area model, that means that that number is composite. Last but not least, what about number 1? Prime or composite? Well, if I made a factor rainbow for 1, 1 times 1. That couldn't even make a factor rainbow because factor rainbows need distinct or different factors, and these are the same. So it does not even make a one factor pair of distinct factors, and it makes only one area model but not of distinct factors. So 1 is actually neither prime nor composite. It doesn't get a label. It's too cool for that. It's its own unique number that is not prime or composite. It's just super special, living its own life, neither of them. And that is the difference between prime and composite numbers.